Paul, are you on the call?
I am. Can you hear me?
Paul Stephens, hi. So you're next, and thank you for being there, but I'm sure you probably learned a few things here, and some of your ideas might result into a power, right? So let me briefly introduce Paul Stephens, the need for data exposure. Is Paul senior technologist at Nokia, is leading the development of the RAN intelligence controller within 5G cloud solution. That's good to have, at least you listen to what we're thinking. That's a great thing. His work focuses on enhancing the programmability of 5G networks, enabling near real-time control of radio resource management functions using machine learning. He also co-chairs the ORAN Working Group 3, which is responsible for RIC and E2 interface. Paul specializes in improving cellular performance in high mobility, high bandwidth environments, and bringing gap between radio technology and operation. So Paul, if you want to talk about your ideas, please go ahead.
Okay, thank you very much for that.
You're going to share your slide, right?
Just about to.
Okay, thanks.
Okay, with a bit of luck, you can see the slide. I do acknowledge that I'm sitting here between everybody and coffee, so I'm going to try and keep it as efficient as possible. And yes, I do agree. I see some potential slight overlaps with what Dilip just presented. Okay. So there's actually been many great presentations both yesterday and today. Oh, sorry, I've just somehow. Okay, that's better. And a lot discussing solutions that were built on ORAN architecture. Nokia has the privilege of participating in and contributing to ORAN Alliance from the very beginning. We've been active in all groups with leadership roles in working groups 3, 4, and 10. And as someone who spent much of the past 5 years as a contributor and co-chair of Working Group 3, I can say that I believe a lot has been achieved in bringing the RIC applications concepts, RIC and applications concepts to reality. As we look towards 6th generation, it's time to consider lessons learned and some thoughts on opportunities for fine-tuning the way ahead. Our discussion today will focus on RAN automation and intelligent programmability. So therefore, from an ORAN perspective, it mostly relates to working groups 1, 2, and 3. Okay. Sorry, there we go. So I call this slide the what do we want and when do we want it? What we want is to further reduce the total cost of ownership, the TCO, and we want to enable agility in the creation of applications. Clearly, the introduction of smart applications is in itself a major contributor to cost reduction. But I would also like to consider the costs associated with the actual creation of those applications. Agility is the ability to minimize the time between concept and realization of an idea in a product. Now, it has been said in the past of low-cost agility and quality that you can have any two of the three. and you have to ask which ones you want. We believe that further simplification and flexibility in the ORAN architecture can bring all three goals within reach. The value is in the data. If you think back to 2G, we didn't realize how easy we had it when the only two dimensions we needed to consider when we rolled out and optimized a network were coverage and capacity. With each incremental generation, the complexity has increased, but so too has the value of the data exposed by the network. And that value particularly helps in the optimization and rollout, but it also helps in the differentiation of the network. Adaptive autonomy is a step towards reduced total cost of ownership while maintaining or exceeding today's quality. Intent-driven AI/ML solutions simplify interoperability. We need to leverage service-based architecture. Service-based architecture moves the focus from a rigid hierarchical architecture to the services and capabilities that we expose. Let's consider an evolved path forward. Time-critical applications can be enabled by the exposure of contextualized RAN services, supported by programmable, cognitive, autonomous RAN operation. Distributed intelligence, meeting the needs of latency-critical applications, supporting the specialized needs of specific slices, resources and programmability where they are needed, AI-powered zero-touch autonomy. So let's start with a look of what's there today. Evolution is complex and it impacts the entire system. Today, we have a portfolio of use case solutions in ORAN. The number of prescribed overlapping solutions can lead to increased development costs. Over-prescription of architecture can drive the direction of implementation and reduce opportunities for innovation. ORAN has not quite reached the point yet where applications are completely portable across vendors. Access to services and enriching information across domains and outside the RAN requires extra effort to facilitate and also tight interconnection. We have no portability between RApps and XApps. Does this relate in some ways to the heterogeneous description that Dilip described earlier? I clearly what he described went way beyond what I've got here, but I think there are some relevant overlaps. So why are RApps and XApps different? Do we need to rigidly categorize timing loops and the applications that work with them? Today's ORAN architecture categorizes control loops as non-real-time, near real-time, and real-time. And of course, there is some merit in this categorization. It does place unnecessary constraints on our solutions. ORAN maps non-real-time and near real-time to separate working groups. This means there are two separate groups creating programmable automation. The ORAN architecture constrains the relationship between these two categories of application. The RApps provide policies for the XApps to use. We need to be able to take a holistic approach to the applications making up a use case. This would benefit from a more flexible interaction between the non-real-time and near real-time applications. Some of the limitations are due to a traditional hierarchical view of the architecture based on platforms and interfaces with tightly defined endpoints. We also need to be flexible in our views about loop timing. There are deployment scenarios in which a fast loop may work in the SMO domain. There are scenarios in which a slow loop in the RAN domain could be the most pragmatic solution. Again, flexibility is the key point. So what might an evolved ORAN architecture look like? A simplified architecture with a focus on service-based rather than platform-centric. Think RIC as a service rather than RIC as a platform. Avoiding any further duplication of interfaces. Intelligent applications located to meet the needs of business opportunities, real-time requirements, availability and quality of data, and AI/ML services. Inherent exposure to enrichment data across domains and from outside the network. Portable intelligent controller applications. Abstraction of complexity towards the applications. Why is flexibility important in the realization of use cases? So ORAN has always supported a monolithic application solution, but it's not limited to the assumption that a single app has responsibility for an end-to-end use case. The component approach to building use case solutions has some major advantages. It enables the app developer to focus on the business logic without all the overhead associated with interfaces. This reduces the cost of XApp development. This approach also enables inter-application APIs to share appropriate logic between associated use cases. Examples might include traffic steering and energy saving. Component-based use cases are more accessible to the mobile network operator, and they provide more access to innovation. Flexibility reduces costs. Providing a common experience for application developers can bring down the cost of application development. Flexibility enables innovation. If everyone produces identical, tightly prescribed solutions, nobody can differentiate. Flexibility can accelerate time to market. Use cases built from a set of applications allows the developer to focus on the business logic, avoiding the detailed overhead of monolithic applications. So we need to enable the introduction of loosely coupled common service environment, loosely coupled applications in the common service environment. Interoperability is determined by interfaces, not architecture. Open RAN has come a long way, and it's well positioned to enable and leverage the full potential of 6G. Simplification and flexibility will enable the innovation needed to ensure that ORAN can lead the industry towards 6G. The value of RAN data has increased with the complexity of every new generation of mobile network. The ways in which we manage, handle, and expose that data may determine future success. The value is in the data we expose. We need to think services, not platforms. We need to rethink the limitations of interdomain applications. ORAN arrived a little late for 5G. The timing is right to make a big difference in 6G. It's time to start proactively planning 6G. Thank you. That brings me to the end of the presentation. I know it's probably slightly shorter.
So Paul, thank you. I think you gave us some food for thought. And you saw a standard process of a scope of a PAR. If you have any specific thought ideas that you think could potentially be considered as a PAR, we can discuss that later on. I don't know, Alex and Mehmet, if you're still on the call, you may provide some guidance to Paul in terms of what could be the next step, because the presentation we are doing today, it is okay to have awareness, but the whole idea was to see, does it have any potential to make it a PAR or maybe combine with other potential PAR? That's the main idea for today's meeting. But these are good stuff, Paul. I appreciate going through it.
May this is Alex.
Yeah, go ahead.
Yeah. So good stuff, Paul. Thank you. This is great. Yeah, you were right that you said it's overlapping, but it's not really like overlapping.
That is true. Yeah.
It's a competitive approach. It's a different philosophy, and especially I like the AI powered autonomy. And so I would say this is a separate project. It would be a very nice standard. It's kind of competing approach. I would say less centralized, or not centralized at all. Actually, it can be kind of it can be all encompassing, but it can be deployed by limited entities and until proved success. I would say that let me tell this in IEEE. We are not prohibited from redundant projects because of our antitrust issues, that our status, non-profit 501c3 organization, we're not allowed to limit competition, even in standards. So redundant standards are okay. And these standards would not be redundant. They're quite complementary. Now, you can look at this as complementary if you wanted, for example, deploy that platform that Dilip was describing using these concepts and this philosophy. But I wouldn't combine them because these are two schools. And combining two schools forcefully is counterproductive. If they come to this themselves, then fine. But I wouldn't force it. I would not recommend them.
Yeah, I agree, Alex, with you. I was listening to Paul. Paul, you have any comment on that? Would you?
Oh, I completely agree. I just saw I saw some overlap, but I didn't intend to imply that that these were the same thing in any way. In fact, there are aspects which I think are quite different.
All right. So what we can do going forward, Paul, I will send you that blank document, a PAR. You may like to fill it out to the extent possible. We can share before even submit. We can share with Mehmet and Alex, and get their feedback, right, and modify that. You saw a sample of that what Dilip did. And at the same time, if you really think you can write a very sample white paper, 3-4 page, just as an additional addendum, when committee looks into it, could help, right? And others can join you in the contribution aspect, right? So, is that something okay with you, Paul?
That's absolutely fine. Thank you very much, and I've learned a lot so far between yesterday and today. So thank you to all that have contributed to that education.
Oh no, absolutely. We all enjoyed all the talks and speakers. So having said that, I just realized you haven't taken a break. And Ole, are you there? You're the next speaker.
Yes, I am.
Is it okay just to take maybe 5 to 10 minutes break? It's 11:11 my watch here. How about 11:20? We start your talk. Is that okay?
Okay.
So 11:20, and Sam, let's put a coffee break sign, and we'll be back around 11:20 Eastern time, so about 10 minutes from now. Thanks.
Hey, Ashutosh.
Yeah.
I just want to tell Paul I would like to contribute to the project.
What is that? Sorry, Dilip. Go ahead, please.
I just wanted to tell Paul I would be happy to contribute.
Oh yeah, you reach out to Paul then. Yeah, anybody like to contribute to Paul's thing, please reach out to him. And Dilip, you and I can talk later about the other part. Okay, let's make it happen.
Okay, thanks very much, Philippe.